Hello and welcome to the second video in my Rigging in Maya series. Previously we looked at joint creation as well as some of the key elements and attributes you will need to be aware of when building your skeletons. The natural step to follow on from this would be to begin looking into controlling those joints. Ideally, with any rig you don't want the animator to be able to directly select the joints. They should be hidden away and instead controlled with custom icons or other attributes. We will be discussing how to create custom control icons in the next video. But those controls need to be able to drive the joints. So in this video we will be talking about the various connections and constraints you can use to achieve this. So let's first look at connections. In Maya you have the ability to connect one attribute to another, or one attribute to many others. So a single value can drive a whole host of others in the scene. To demonstrate this, I'm just going to create a joint and a very basic control icon. So if you remember from the previous video, I'm just going to go use the rigging shelf tab, and I'm just going to use the create joint tool, hold down X, and I'm just going to create one in the center of the grid. So there we just have a basic joint. I'm not going to play around with any of the attributes or the rotation orders or anything like that. Now for my control, I'm going to create a NURBS primitive circle, like so. And I'm going to move that up just so that we can see it clearly. So we have a basic control now, and I'm just going to adjust this, display, drawing overrides, enable overrides, and then I'm just going to change the color to not green, yellow. So that just makes it stand out a bit more. And like I said earlier, we're going to look into creating your own custom controls in the next video. So here we have a control and we have the joint. And as mentioned before, ideally we want to be able to hide the joint. So all we're going to do is the animator is just going to animate with this. They're not physically going to move the joint around. Now the reason we don't want them to edit the joint, if I move the joint up slightly, let's move the control up. Now the problem we have now is the joint has this Y value on it, whereas the control, now that has a Y value on it as well, but what we can do with the control is we can go to freeze transformations up here. We can freeze that and that resets all these and zeroes them out. Just going to delete the history as well, and that just leaves it nice and clean. And that gives you a nice level control to use with nice zero values. Now the problem with the joints is we can freeze the transformations, but it doesn't work on the translate values. So if you're an animator, for example, if you're just using the joints directly, if you want to zero out the rig, obviously if you zero this out now, it's going to reset all the joints back to, you know, the root. This is why we use controls, because controls can be separate, and there's lots of other things that you can do with controls as well that you can't do directly with joints. So as a basic rule, you should always use controls to drive joints and not use joints directly. Anyway, let's get back to connections. So just to demonstrate this, I'm just going to zero this back out, and you'll see why in a minute. So when it comes to connections, all they are is you are directly connecting one attribute to another. And there are a couple of ways that you can achieve this. We can go to Window, General Editors, and go down to Connection Editor down here. This opens up this new window. And all we do is we select the control and reload left, and we select what we want to connect to and we reload right. And we can open these attributes here. Basically you can connect all the rotations directly like so, and you can see in the channel box they've turned yellow to indicate that the joint is connected to something else. Now what that means is those rotations are locked, so you cannot rotate the joint. Instead, they're being controlled by the controller. As you can see, as I rotate this around, the joint is rotating too. And that works quite nicely. A direct connection, there's no extra nodes involved, You don't have to use set driven keys, which again add extra animation curves on top of that. You've got a direct connection between one attribute and another, or in this case, rotate XYZ and rotate XYZ. You can connect them individually. So if I break that connection there, say we only want rotate X. So now if I rotate Y, nothing happens, or Z. If I rotate X, the joint rotates too. And you can see it in the channel box, it's highlighted in yellow. So that's one way that you can connect those attributes. And again, in here, all this is showing are the very basic attributes that we can see here. If we wanted to, we could show the hidden attributes, show the attributes that are connected only, and that's just telling me that rotate X is the only one connected, so it's just showing me here, and show non-keyable. And that just brings up all of these, pretty much every attribute associated with that joint. Now it says it's not the non-keyable, but you can still connect other attributes to them. If I deselect that, or if I select something else, let's select translate X, you'll notice that these that are greyed out mean that you cannot connect that to them, but the ones that are in white and bold now mean that you can connect them. If I select the rotate, which does obviously the 3 attributes at once, now a lot of these are greyed out. So that's just a very basic overview of using the connection editor just to connect one attribute to another. Now to go a step further, you could have your own custom attributes which are added to a control, and again we're going to cover this in the next video. But then those custom attributes that you add on here could then control something else associated with the joint. Perhaps it's the radius, perhaps it's the visibility. You know, the possibilities are endless, but that's just how you can use direct connections. So what I'm going to do is I'm just going to disconnect. Let's turn that off so that that's freed up. There we go. So the other way that you can connect one attribute to another is to use the node editor. And I'm just going to find that now. Window node editor here. So if we open this up, so I'm going to select the control and I'm going to select the joint, and then I'm going to click this button here, which is just going to add those selected nodes to the graph. Now we don't need this shape node, so I'm just going to click this button next to it, which will remove that. And that means we can just focus on the nodes that we want. So we have the joint over here, and we know that we want the NURB circle 1 node here, which obviously should have a better name, to drive the joint. So I'm just going to open those up, and as you can see, we can see all the attributes here. You know, everything that we want to work with. So it's very similar to the connection editor, but I think the node editor is just a lot more user-friendly, and I tend to use this a lot more. But just as we did with the rotation before, we could just select rotate here and drag across and connect to rotate there. And that's just done the same thing. You see up here, we've connected that rotation. You can also select that and delete it, and we could just rotate X. Could go to rotate X there. And I mean, you could do this with the connection editor as well, but you could say rotate X needs to control rotate Z, Y to X, Z to, that didn't connect, did it? There we go, right to X, you know, and just play around a lot with that so that the rotations are affecting different axes. And that's useful if, as we discussed in the previous video, if you have to change your rotational axes, you know, so maybe Y is pointing down the bone, you may need to have the Y rotation on your icon controlling a different rotation on your joint because the orientation is different. So that just gives you a bit more flexibility when it comes to building your controls and working out what controls what. So the problem with connections is the values that are on the control will be applied to what you're connecting to absolutely exactly one for one. So if let's connect the translations. So this is fine because the joint is at 0, 0, 0 anyway. Us adding a connection from this control, which is 0, 0, 0, means it doesn't need to move. And we can move this around and the joint follows happily. So if we break that connection, now what if our joint is up here somewhere, you know, and it's part of an arm or something? Put the control up here. I'm just going to hold down V, which will snap it to the middle of the joint and move it above there. And then I'm going to freeze the transforms on that control. And as discussed earlier, we can't freeze the transforms on these translation values on the actual joint itself. So what happens now is if we connect the translate from the circle to the translate on the joint, it's going to snap back to the root. Because the control is 0, 0, 0, it's snapping the joint back to 0, 0, 0. And that's where using direct connections can fail, really. The values are exact. Now, there are ways around this. You can use utility nodes, which again I'm going to cover in a future video. But you could put a utility node in between these connections here and then create an offset. So let's just put that joint back like so. So what you would do is you would put a utility node in between these. So this translation value here would have these values added to it on the utility node in the middle here, and then it goes from the utility node in the translation. So you get an offset that way. So that's one way around it. But the other way that you can connect your control and your joint and maintain a good offset is to use constraints. And that's what we're going to look at next. So now we've looked at the benefits and also the limitations of using direct connections. Let's move on and have a quick look at constraints. And constraints are very, very useful and very powerful nodes in Maya. I use them all the time in my rigs. I don't think I could do them without them. Well, that's not entirely true. There are ways that you can get around not using constraints, but things just get complicated then. So constraints are hidden in if you need to go into the rigging menu set, and then you've got a constraint menu up here. So as you can see, we've got lots available, and we're just going to look at these main few up here. So the parent, point, orient, scale, and aim. The pole vector constraint, we're going to leave that and we're going to look at it in a future video when we start to look at IK and FK. So essentially these will constrain the movement of the joint to the control, but in different ways. So let's have a look at the first one, parent. So the way you use it is you select the control first, you select the joint that you want to be constrained second, and then let's just open up the options, reset the settings. So as you can see here, before we apply this, we've got lots of options available to us. Now maintain offset, that will just mean that the joint will stay where it is, rather than being snapped to the actual control itself. So if I click apply now, we can see down here that the joint now has these blue icons on here, which indicate that this is being controlled via a constraint. And because we had maintain offset enabled, the joint stayed where it was. So if I undo that and turn off maintain offset, click apply, see the joint then snaps to where the control is. Now most of the time you'll probably use maintain offset because you want to leave your joints where they are. Another option available to you if you didn't want to have maintain offset on it works on the pivot point for that control. So if I hold down Insert, then hold down V, and with the middle mouse button just snap this to the center of the joint. Now without maintain offset switched on, if I click apply, you see the joint then doesn't snap to the control. And we can rotate that joint, we can translate that joint, and that's pretty much what this constraint does. It allows you to control the joint using the translations and rotations of the control. So let's just undo those, like so. Now you do have the option, as you can see here, is to just constrain via all the translation values, or you can just do all the rotation values, or you can actually specify which axis you want to be constrained. So it's quite, flexible, and you can change this according to how you want the joint to be controlled. Now I'm demonstrating this controlling a joint, but obviously a constraint could be anything. You could constrain a control to a control, or a control to a group, or anything really. So that's the parent constraint. Let's just apply that there. Now again, previously when I applied it without maintain offset on, I moved the pivot point to where the joint was, which meant that the control's rotations and translations were pivoted around the actual joint. But because the pivot point for this control is up here, when I rotate this, you'll see we have an offset. So it's pivoting around the actual control instead. The same with translations. So another way to think about the parent constraint is basically, if I undo this, let's go into our outliner. If I parent that joint to the control, it's pretty much just doing the same thing. The reason that we use constraints is because in your rigs, you do want your joints or your skeleton hierarchy to be outside of your control hierarchy. You don't want to end up with a hierarchy full of controls that have joints nestled underneath them. Especially if you're working on a game rig, you want your skeleton to be as clean as possible, so that when animation is done and you're exporting that to a game engine, you don't have extra nodes in your hierarchy, because this can cause problems. So the solution is to use constraints. So if you're wanting to parent one thing to another, use a parent constraint instead, rather than parenting it beneath the control. So let's apply that again. So that's the parent constraint. So the next one is the point constraint. And all this does, if we apply that, this just constrains the translations, as you can see in the channel box. So we can rotate that, and it's not having any effect. That is just going to manipulate the translations. So if I delete that constraint there, let's try and apply a parent constraint just with the translations. So you see we get very similar results, but the problem is, well, it's not a problem really. If we're using a point constraint, the translations are affected, but when you rotate it, nothing happens to the joint. When you're using a parent constraint instead, but just using the translations, you can move it around, but then when you rotate, as you can see, we have an offset because it's still moving around the pivot of the control. So that's the problem. You know, if you decide, oh well, why don't we just use a parent constraint and use the translations instead? It's acting as if it's still parented to the control, but the rotations are being ignored. So you will still get this offset as the control rotates. Now in some instances that may be perfectly ideal for what you want to do, but in other situations it may be that the point constraint is better because you want that complete freedom to then do whatever you want with the rotations. Let's zero that. So I'm just going to delete that node again. So next we have the orient constraint, and that is just the opposite to what the point constraint does. I'll use maintain offset again, although we don't really need to because the rotation values on the controller 0 and the rotation values on the joint are 0, so we didn't need to use maintain offset. If I click apply, as you can see it's just affecting the rotation, and if we can move the control around it's not going to have any effect because obviously the translations aren't being affected. So again, if we go back to the parent constraint and instead we just apply the rotations, so if I rotate this and then move the translations, so there's not much difference between the orient and just using the translate rotation. So it's worth playing around with these just to get a good idea and a good sense of what you need from that control. So finally we have the scale constraint, and that is simply, it's pretty much the same. Again, you've got a maintain offset value, click apply, and we won't see it here because obviously the joint doesn't scale, just the offset does. But then we've got the constraint there, we can see it in blue, so we could scale this icon and the influence that the joint has on the mesh will scale as well, so you can also use that, and that's quite handy if you're setting up sort of stretchy limbs or squash and stretch and things like that. So those are these 4 main constraints here, and as I said before, there's a lot more you can do with these. Now with connections you have one direct connection and that's it. Unless you start adding in different utility nodes, things can get complicated then. You're basically looking at a direct connection. Now the beauty of, let's just get rid of these, the beauty of constraints is you can apply more than one constraint. So let's for example say we have this joint and I want it to either follow this joint or this joint. So you can see this is where your IK-FK blending can come into effect. You have your main skeleton and it can either follow the IK skeleton or the FK skeleton. So what we do is we select the 2 joints first that we want our main joint to be constrained to. So the last joint will be the joint that has the constraint applied to it. If I click parent now, what we can see is it's gone blue because the parent constraint has been added, but down here we have joint 3 and joint 1, and these are weight values. So that's our joint 3 and that's joint 1, so it's just use those names. And next to those you can see we have a value of 1. So if I set this, if I slide this one actually down, oh, I know what I've done. Right, so the issue I had there is because I had maintain offset on, which we don't want in this instance because we want this joint to either snap to this one or to this one. So we don't want it to keep an offset. So let's try that again. Maintain offset is turned off. Click add. Now we saw that joint move slightly because what's happened is it's moved, so it's directly in between these 2 joints. If I move this one down or move this one around, you can see that our main joint is equally in between joint 1 and joint 3. So going back to what I was trying to show you before, we have these 2 values here, which are a value of 1, and that is making this joint stay in between both of them. If I set joint 3 down to 0, you can see our main joint moves over to that one. So we set that back to 1, and the same with if we set joint 1 down to 0, it's going to move over to this joint. So we can use these attributes to control where our main joint is going. And obviously we've only used it with 2 joints. You could use it with 3 or 4 or as many as you need it to. But for this instance, and the example I used earlier, this could be the IK arm, this could be the FK arm, and this could be the arm that's bound to the skin. So you can use that parent constraint to blend this joint between those two. And obviously you would have an attribute on this control here, so that's FKIK blend, say, just a basic name. And that attribute will then control both of these attributes here. And like I say, we would probably use a utility node to do that, or you could use a set driven key, but I'll go over the process of doing that in a future video. So those are the 4 main constraints. What I want to do in the next part of this video is investigate the aim constraint. And I'm sure you've seen this a million times, but the most popular way to use an aim constraint is to create a look at control. And this is where you have a control here and you move it around and the eyeball will always look at that control's position. Now, yes, this is the most popular way to demonstrate an aim constraint, but aim constraints are very powerful constraints. They are used widely in rigging across all different aspects. One that comes to mind is to help control shoulder and wrist rotation so that you get a nice natural deformation in those areas and are able to move your rig around freely without worrying about areas twisting or bending or not deforming correctly. So aim constraints can be used in that sort of setup. But yeah, for now I'm just going to focus on the basics. So let's just look at how you would use an aim constraint just to get these eyeballs to follow these controls. So we're just going to go to the rigging menu set and go to Constraint again, and I'm going to go to Aim and open up the options. Now there's a lot more in here to do with aim constraints compared to a parent constraint, for example. And just looking at this, it just looks very complicated. But I'm just going to reset the settings just to make sure we're looking at the same thing. But let's just add a basic constraint and see what happens. So we want this eyeball to follow this. So we basically want to constrain this joint to this control. So select the control, select the joint, click apply, and you can see with the default settings this isn't working, and that's because our aim vector, which is the axis which needs to point towards the control, is set to X, whereas if we select our joint, you see the Y-axis here is the one that needs to be the one that points to the control. So let's select the control again, select the joint. Now one good thing about aim constraints is, let's say we applied that and it wasn't right. You can go into the attribute editor, and then if we select the constraint node, we have all the options down here, so we can edit it after we have applied it. So this allows you to play around with the settings to get the setting that you want. So I know that the aim vector is set to X, but I want it to be set to Y. So I can come to aim vector here, set that to 0, and then set it to 1 for Y. And there, that's correct so far. But now we have Z pointing down. If we look at the other eye, you see we want X pointing up, whereas X is pointing out to the side. So again, let's go to our aim constraint and let's have a look. So the up vector for this is set to Y, which is clashing with the aim vector. Now what an aim constraint tries to do is it uses the aim vector to point towards whatever you're specified to, whatever you've told it to look at, but it also needs to know which axis points up. So by default, world up type is set to vector, And what this means is you can specify this vector here. So we're basically saying here we want the y-axis to be the up axis. But down here we're now saying, well, the up axis is going to be y as well. So you can see we're getting lots of clashes. So it's very much like when we looked at joints in a previous video. When you're setting it up, you need an axis to point down the bone, but then you need to specify which axis points up. So here we've got we're saying we want the y-axis to point up, but then we want it to point up in the world's y-axis as well. So we're getting issues here. So let's go back. We know we want the x-axis to point up instead. So we go to our up vector and we say we want x to point up. And you can see that has updated automatically because we have we're editing the aim constraint. We're not creating a new one. And I'm going to set that one to 0. So all we've said is we want y to point down towards the locator or the control here, but we also want x to point up, and the up axis is the world's y-axis here. So I hope you sort of followed along there. So let's do it on the other eye. We select the control, we select the joint. So we want the y-axis, so we don't want that. So we want the y-axis to point towards the control. So we change that to y. We want the x-axis to remain up. So we'll set x in there and we'll remove that. Now we know the world axis y is pointing up. So we can set our world up vector to y, which it already is. Click apply and that's worked. Now obviously if we wanted our up axis to be down x or down z, you can change that as well. So just as a quick test, let's close this. And as you can see, the eyeballs now follow those controls. So this is quite a basic setup, and this may be absolutely fine for your rig. But we do end up with problems with just using the basic default settings. So let's say if the head ended up rotating round like so. Now you can't really see it with this. So what I'm going to do is I am going to just display the rotational axes, and I'll do it on those as well, just to be sure. But you should see, so if I just rotate these up, once we get to a certain point, see, we end up with a flip. And that's because when we've been setting it up, we've told the constraint that we want X to always be pointing up to mimic the world scene's sort of up axis. So from here, X is pointing up. It's still trying to point up, but at this point where it's starting to point down, the joints flip because it's trying to force X to continue to point up. So that causes problems because we don't want, if the character sort of rolls or something, or it needs to do something more extreme with its head, you don't want the eyeballs flipping. Or you could have this set up with something else, and as soon as you rotate up past that point, you end up with it flipping. And this causes no end of headaches when it comes to creating rigs. So let's remove those constraints and let's have a look at other options available to us. So let's not remove those constraints, because as I said before, the beauty of these is you can edit them as you're working on them. So let's look at this constraint. So we know the issue is the up vector because our aim vector is fine. We want Y to point at the control, so that is fine. We don't need to do anything with that. So let's have a look at the different world up types that we can choose. Now scene up will pretty much do what our vector is doing now. It will just follow the scene's sort of the world axis basically, and it will just, but that locks it. If you see, if we select scene up, this is grayed out then, because what it's saying is just copy the scene, whatever the scene is pointing up, so the y-axis, that is the world up type. Whereas the difference is with vector, you can specify. So we said we wanted X to point up. Now here we have it set so X is going to point along Y, but you have the freedom to point it in any of these directions. So if I set that to 0, we set that to Z or something, you can see it changing because it's trying to look along that. So if we set that back to Y, and that's just the same as scene up, so nothing changes there. So if you know you want your vector to just be these default values, so set to Y, you could just use scene up. So the next one is object up. And here you can specify an object that you want this to always try and look at. Well, basically it's already looking at an object, but what you're saying is we want the up axis to also try and follow that object as well. Now at the moment we haven't got an object specified. That's why it's changed, because it's tried to put in some sort of default values. It's trying to use the world root. So we need to put in an object just to make sure everything works. Now you don't have to use the control. You could use a separate object to give you a bit more flexibility, but just for the purposes of this, I'm just going to use the control as well. So if I put that object in, so this is one of those instances where if you notice the axis has flipped, and I suspect that is because when we created our look at control, the eyeball actually looked down slightly when it started to aim. So what I'm going to do in this instance is I'm going to delete that constraint. I'm going to reset the rotations, get it back to basics. Now we could just make sure that we add on maintain offset as well if we didn't want the eye to move down. So let's select those, and we want our constraint aim. So in order to prevent the eye from rotating down slightly, I'm just going to use maintain offset. So we want Y to point down the bone, and we want to set this to object up, and I'm going to put that control in the world up object. And we want X to point up. So if I click apply, now those axes are a lot better then. They didn't flip upside down. So like I say, either it was because of the maintain offset, so let's just try it. Turn off maintain offset, click apply, yeah, so it's because of that. So that's my fault because I didn't check that the eye was rotated correctly. It's just pointing up slightly. But you know, you come up with these issues all the time, and I could edit the video and just crop this out, but it's probably good for you to see, you know, sort of problem solving as you're going, in case you come up with some of these issues. So I'm going to put maintain offset on, click apply. Let's do the same with this eye. Obviously we want this control instead, which is right eye. Click apply. So the issue we were having was that as we were rotating around like so, because X was always trying to point up and it was trying to follow the scenes up, once it started to come to a point where it was pointing down, it was starting to flip. But as you can see now, we don't get any flipping because it's being told that X is pointing up sort of relative to the pivot point of the control. So that's a way of fixing that issue. If you end up with flipping like so, see we can rotate it all the way around and it doesn't flip. You know, so just using object, let's have a look. Object up instead, that will rectify that. Now the problem is it doesn't fix all issues. We can rotate up like that, but as we start to rotate around like so, as you can see, the Z-axis is starting to point down, so we're ending up with, even though we fixed the twisting in one plane, it's happening in another. which isn't great. So what we can do instead, let's have a look at our other options. Now instead of using object up, we could use object rotation up. And again, this is just... So now Z is pointing up. So we need to experiment with some of these, because the problem we have is the joint's rotational axes are different to the control's rotational axes. So sometimes you just have to experiment with some of these just to get the one that works best. But basically what it's trying to do is it's saying this object's up should follow the object's basically, right, I'll start again. What it's trying to do is saying, right, take this object, which is the right eye control, and use a specified axis as the up axis. And what you can see is as I rotate this, like so, the eye is rotating with it because it's using that axis. So it's saying X needs to follow the Y axis here. So if I do the same with this one, so now we can rotate around this axis and it works absolutely fine. And the issue we were having before was as we turned around, you know, Z was starting to go down, but this is much better. As you can see, the axes are completely solid because they are using the objects here to control which way they are pointing up. Now what this does allow us to do is say, yes, this is working fine, our up axis is working fine, there's no flipping, but then we've got a bit of extra control. So I can say, well, I could want to tweak that a little bit just by rotating like so. So it gives you a little bit more flexibility, but it also helps to eliminate those issues where you get the axis flipping or turning or rotating when you don't want it to. So that is basically setting up aim constraints and the various options available there. You know, and as you've seen, they can be quite tricky to get your head around, but once you sort of understand the basics, you can experiment and play around with them, just like we did. We applied one and it didn't work, but then you can go in and you can edit it to get it to do what you need it to do. And like I say, there were a few bumps in the road on this bit of the tutorial, but I'm not going to edit those out. We'll leave them in. You know, if you have a similar problem when you're creating an aim constraint, hopefully this shows you sort of how to problem solve and get around it. So we've come to the end of this second video in this series, and we've looked at connections and constraints. So what I'd like to do is in the next video take things a step further, because we know how to build and edit joints. We know all about how to connect things to joints. So now why don't we have a look at how to build your own custom controls? So if you found this video informative and helpful, please like it and leave a comment below. Comments are also always handy. Also remember to subscribe so that you can keep up to date with future videos in this series, and I will see you on in the next one.